So in section 2.1, we got a very general overview of what sets are. We figured out the 3 different methods we're going to use to actually write them, some symbols involving them, the cardinality, just lots of general basic concepts. A nice intro to sets is what we have. Today we're going to look at what subsets are, and we're going to start doing some operations with our sets. By operations, I don't mean adding and subtracting. We're going to look at things like the union or an intersection, complement, things along those lines. So to start us off, I do have 5 sets, and the one that is denoted with the capital U is known as our universal set. The universal set will have all of your elements for a particular problem set. So if you take a look, everything in sets A, B, C, and D are also found in set U. So U is the universal set for our given situation. And I do also have those written on the board up here too, so as we go through our examples, we're going to keep referring back to those, okay? The first thing we want to take a look at, it's called the complement of a set. And no, we're not going to tell it that it's beautiful or that it's handsome today. The complement of a set, we denote that by whatever the set name is. In capital A, I'm just using that as generic. It could be any capital letter. And then it has what looks like an accent mark next to it. That's how we denote the complement of a set. And what the complement is. The complement is the elements that are in the universal set but are not in set A. It's the elements that are in the universal set but are not in set A. So basically take your universal set, take out the elements in set A, or whatever the set is you're trying to find the complement of. I wanted to write the definition of the complement using set builder notation because I know that's something as you guys were going through that first section, some of us were like, oh, set builder notation, feeling kind of shaky on, so I'm hoping maybe the more we see it, the more we'll kind of grab a hold of it. That's my goal. So if we interpret the set builder notation, this is our complement of set A. And remember that variable is representing any element in our set. So the X is any element in our complement. Our E, kind of that squished down looking E, remember that means element of capital U is a universal set. And this symbol where we take our, looks like a squished down E, our element of symbol, and we put a slash through it, means it's not an element of. Kind of like you guys are used to, if something is not equal, you take your equal sign and put a slash through it. So if something isn't an element of, we take our E and we put a slash through it. So if we put this all together, I broke down the different pieces, if we put it all together, we have our elements in the complement such that the elements in our complement are elements of the universal set, and they are not elements of A. So they are elements of our universal set, but they are not elements of A. So let's take a look at what that looks like. Let's look at our sets that we had on that opening slide. Should be in the upper left-hand corner of your handout. And let's find a complement. The easiest way for me to show this, I'm going to write down the universal set. You don't have to rewrite it, the universal set. And I'm going to write it all out. We have the elements, we have the natural numbers 30 through 40. That's the entire universal set. And now the complement. The complement of set A are elements in the universal set that are not in A. So the best way for me to show this is to take the universal set and then cross out anything we find in set A. Set A is 30, 35, and 40. So I'm going to remove 30, 35, and 40. What I have left is the complement. So I start with my whole universal set. I take out the elements of set A. The leftovers are the complement. I don't know if I'm going to squeeze those all here, but I'll try. So just take a minute here, guys. I have up here the complement for B and C. Just take a pause here, try them out, see where you're at. I'll be around to help you out. Just to make sure you're on the right track, I'm going to put the complement of B up just so you can check yours before you move on to C if you haven't gotten to C already. The complement for set B should be 31, 33, 35, 37, and 39. So remember, you start back over fresh with the universal set, take away anything you find in set B, leftovers are the complement. Go ahead and try C if you need to. All right, guys, who's feeling confident out there? What do you think for C complement? What do you think? Somebody lay it on me. What do you got? What do you got, Jacob? All right, so 30, 31, 32, 33, 34, 35. What do we think? Agree? Our next idea is the idea of a subset. A subset is if we have every element in set, and again, sets A and B, they're just generic. We worked with sets in that first section. We know not every set is named A or B. It's just the generic placeholder there. If every element of a set A is also an element of set B, so everything in A is also found in B, A is a subset of B. If every single element, every single thing in A is also found in B, A is a subset of B. How do we show that a set is a subset of another? The symbol for that, I think it looks like a smashed down C with a line under it. Some people say it looks kind of like a sideways U with a line under it. Kind of up to you. So if we want to show that set A is a subset of B, we put the capital A, we put our symbol, and then we put B. So whatever we think the subset is listed first. So we have A is a subset of B. Every set is a subset of itself. Because every element in set A, well, it's going to be in set A. Every element in set B is in set B. And also the empty set is a subset of every set. Remember, the empty set has no elements in it. It is considered a subset of every set. And these two pieces of information are going to become very important as we start talking about how many subsets a set actually can have. If a set has, and I just used the variable n, it's just a generic placeholder there. So n could be any whole number actually, because we could have 0 elements. Whole numbers contain 0, natural numbers do not. So if a set has however many elements, then there are 2 to the n subsets. So if we need to figure out how many possible subsets there are, we have 2 as a base, and then our number of elements becomes our exponent. So if we want to find all the subsets, and I just used a pretty basic set, 1, 2, 3. If I want to find all the subsets, first of all, I want to know how many there should be. So I'm not trying to rack my brain and come up with extras when there's really not anymore. So we're going to use our little formula, our base of 2. The number of elements in our set, the set is 1, 2, 3. There are 3 elements. 2 to the third, remember, I know sometimes we get in a hurry. It's 8, yes. 2 times 2 times 2. So we should have a total of 8 subsets. The ones that people forget the most, I have this table built out. You wouldn't have to make a table when you come across this kind of question. I'm doing it just for a nice visual purpose here. The ones that people often forget about are when you take all of the elements in the set. Each set is a subset of itself. So if there's 3 elements, one of the subsets is all 3 elements. And remember, changing the order does not create a different set. So if I write 2, 3, 1, it's not a different set. Now if we just take 2 of the elements at a time. So what that would look like, a subset could be the elements 1 and 2. It would be the elements 1 and 3. And it would be 2 and 3. Any I missed? Taking 2 at a time? Remember, order doesn't matter. It doesn't make it a new set. So 1, 2, and 2, 1, they're the same thing. If you just take 1 element at a time, remember our sets can just have 1 element, then I would just take 1 and make it a set. 2 and 3. When thinking about subsets, these middle 2 rows, those are the ones that people usually think of. They think to take 2 elements at a time or just 1 element by itself. The ones that people forget about are the first one, where we take all of the elements, every set's a subset of itself, and this one, the 0 elements, that empty set or that null set, is always a subset, and that's the one that gets forgotten the most. I guarantee it. So you could put empty braces or the circle with the slash. I'll take either one. The circle with the slash through it, that symbol's more commonly used, but I'll take either. They mean the same darn thing. So whatever you like. Completely whatever you like. So now just to kind of hit home some of the subset ideas here. Take a quick peek. Take a minute. See what you think the answer to this would be. So is 1, 2 a subset of 1, 3, 2? No, it's not. Because 2 is not found in that second set. 2 is not an element of that second set. All the elements have to be found in there for it to be a subset. I can't be missing a single. Our final idea was subsets, and then we're going to get into those set operations. If a subset is not equal to the original set, then it's a proper subset. So if it's not equal to the original, then it's called a proper subset. So on the little table that we made, I'm just going to take a quick flip back. I will come back to this, so if you didn't jot something down, I will get back to it. So on this table, here's what this means. To be a proper subset, it cannot be the set itself. So all of these would be considered proper. The only subset that's not proper is the set itself. That's the easiest way for me to describe what a proper subset is. It's any subset that is not the set itself. So all of those would be proper. Now to denote a proper subset, same symbol, but you take the line away. Same symbol, but you take the line away. So we would have the set 1, 3 is a subset of 1, 3, 5. And it would also be proper since it's not the set itself. So it would also be proper because it's not the set itself. And then just to hit this idea home, one, 3, 5 is not a proper subset. Again, as soon as we put a slash through that symbol, we throw in that word not. It's not proper. Since 1, 3, 5 equals 1, 3, 5. Now, if you wanted the number of proper subsets, take a look at what we did on our table. To get the number of subsets, we did 2 to the n. Then the only one that's not considered proper is the set itself. So we take our 2 to the n, which finds us all the number of subsets that we have, and then we take away 1 for the set itself. You subtract 1 because the original set is not proper. Okay? We're just going to look at, there's only 4 set operations that we're going to concern ourselves with. And finding these, they go pretty quick. So bear with me on the definitions, because when I put the definition up, it's going to look very wordy. I'm going to help you cut that down. Okay? You want to write every word? You absolutely can. A set operation. It's a rule for how we can combine 2 or more of our sets to form a new set. So set operations, that's how we combine our sets to make new ones. The first one we're going to look at is called a union. The union of 2 sets, and it's symbolized, and I like this symbol a lot because it looks like a U. U for union. The set of all elements that are in set A or B or both. So we have all elements in A, B, or both. This one isn't super wordy, but if you want to try to cut it down, you can. I hit the highlights with the underlined part. So you have the union of 2 sets. I would get the symbols down for sure. So if we're uniting 2 sets, we're going to take all the elements and make one big set out of them. Do not write repeated elements, and we'll see that in just a minute. The word or can sometimes be used also to indicate a union of 2 sets. So I want everything that's in set A or set B. So that keyword or, I want everything that's in A or B. Just based off of the definition, we're going back to our original sets. Based off of this definition, see what you would put down for A union C. Just take a shot. I don't expect you're going to get it right. Just based off the definition, what do you think? So if we take a look at set, and I'll just go ahead and jot the sets down here again. Set A was 30, 35, and 40. Set C was everything 36 through 40. So for the union, I want everything that's in A or B, or it can be in both. That's okay. So basically, when we unite 2 sets, we take the 2, we smash them together. We don't write repeated elements. So we see that 40 is in both sets. I only write 140. We talked earlier, the order doesn't matter. It'd be more proper to put them in that nice numerical order, but you wouldn't necessarily have to. There's no pattern to this set, but I would. I mean, that's just me. That's what I like to do. So I would put 30, 35, 36, 37, 38, 39, and again, I just write 140. So if you need to make that note to yourself to not write repeats, like we had one of the homework questions was, write the elements for the letters in the word stress. Stress has 3 S's, but we just need to write it once. We just need to write it once. So take a minute. If you want to chat with the person next to you, you can. Find for me B union C. Again, we're using those same sets that we started off with. I'll put B up here just so we have it. All right, so we're going to take set B and set C. We're going to make one superset out of them. But we're not going to write any repeated elements. We're not going to write them more than once is what I mean by that. We're going to write them. Like A and C, they both had 40 in it, but I just wrote 140. I still write it, but I just write it once. All right, so B union C, we're going to have 30. 32, 34, 36, 37, 38, 39, and 40. But notice set B and C, they have 36 and 38 in common, but I just write them each once. I still write them. I write the elements that they share, but I just write them once. The next set operation leads right off of this one. It's the intersection. The intersection of sets A and B, the symbol for it, we take our union and we flip it upside down. And it's the elements that are common. So what are the elements that they share? What do they have in common? And if you think about it, when two streets intersect, that intersection is the area that those two streets share. It's the area that two streets have in common where they intersect. So I want to write down what the two sets have in common. That's what I'm going for. So using the same sets, I know some of you are faster writers than others. So if you write a little faster and you want to take a shot at what A intersects C would be, go ahead. All right, so A intersects C. I want the elements that are common, or what are the elements that they share? A and C, if we look at our sets, the only thing they have in common is the element 40. Do you think it's very possible that an intersection might not have any elements at all? Yeah. There's going to be times we're going to have sets that they don't have anything in common, and that's okay. Don't freak out about it. I'm not trying to trick you if you come across a question like that. Just sometimes they don't share anything. That's okay. All right, so how about B intersects C? 36 and 38. Now, if you look, these are the same sets we were uniting on the last one. We did A union C and we did B union C. Look at how those two are different. Look on your sheets. Look how they're different. Union, we take both sets, put them together. We still write the common elements. We just don't write them more than once. Intersection is what they share. Just like where two streets intersect, it's the area that those two streets share. It's where they overlap, if you will, if you would like a different word for that. Our third operation, here's where we have to be careful. It's the difference. It's the difference. I know some of you out there have had math vocab so pounded in your head, as soon as you see difference, you're like, yeah, Miss Golly, subtracting. And hey, it's even a subtraction symbol. But we're not actually going to subtract elements. We're not going to do like 30 minus 32 and now we've got a negative 2 in the set. We're not actually going to do anything with the number piece. Because remember, sets don't always have to be numbers. We had sets with colors and types of vehicles and classes and things like that. So what we do is we start with everything that's in the first set. Start with all the elements in the first set, and then we just take away any that are in the second set. So start with set A, and we'll take out anything that's in B. The leftovers are the difference. We do not actually subtract the sets themselves. And I'm just going to go ahead, I don't expect you to race ahead to the example, I'm just going to jot these two sets down just so we can see.
So AUB and BUA is the same, but A minus just like the regular math.
All right, so we start with whatever set is listed first. So set A is what we start with. So we're going to start here. And we take out anything from set A that we find in set B. So what do A and B have in common? Just 30. So the difference of A and B would be 35 and 40. That's the elements that are different in A. So you take out anything that's common. You always start with the first set. The other elements in B, we don't care. We're starting with A, taking out anything we find in B. So for B minus C, you're going to start with B. And take out anything that you find in C. So our concern is set B. What do B and C have in common? What am I going to take out? 36 and 38. What remains from that set B? That's our difference. The other stuff that's in set C, whatever. See ya. It's gone. It doesn't matter for us. Okay? Doesn't matter. Our final operation, and here's where we have to be careful, because we're so used to some of our symbols. It's the Cartesian product. Now, I know as soon as we see product, we're like, yeah, we're going to multiply. When you guys plot points, though, you're actually making a Cartesian pair. So actually, I know it looks like A times B, but we're actually making ordered pairs. In the ordered pairs, I know you guys are used to X and Y. The first piece of the ordered pair comes from the first set listed. The second part of the ordered pair comes from the second set listed. So we'll take an element from A and pair it with an element from B. So we are literally making ordered pairs. So we have A, so we're writing all possible ordered pairs. First from set A, second from set B. Now I know we think, oh, it should be multiply, Miss Guy, that's that X. No, we're actually going to make ordered pairs with our sets. We're not going to multiply 30 times 35 and start getting all these giant numbers. Remember, sets are not always numbers. I chose sets that are numerical. I feel like they're a little easier to work with than having to write out all these words for colors or subjects in school and things like that. Just help make this a little simpler. So A and D. I chose A and D because they are smaller sets. So A and D. We haven't used D yet. It's this nice little set that I created just for this particular operation, because otherwise you get a ton of ordered pairs. So what we're going to do is create ordered pairs that list elements from set A first, and then set D. The easiest way I found to do this so I don't miss any ordered pairs, here's the easiest way I found. I start with the first element in the first set, so 30, and then I pair it up with everything in the second set. So we're going to do 30, 38, then we're going to do 30, 39. Then I start with 35, pair it up with 38, pair it up with 39. Then I start with 40, pair it up with 38, pair it up with 39. Now you might find your own way that makes more sense to you, and that's fine. I always start with, I do each element from the first set and pair it with everything in the second. Then I move on to the next element of the first set, pair it up everything in the second. Then I don't miss an ordered pair. Now sometimes you pair a set up with itself. So what I start with, I'm going to start with 30. I'm going to start with 30 and pair it up with 30. I'm going to pair 30 with 35.
Please disregard that bell.
And I'm going to pair 30 with 40. So I took the first element in set A, and I paired it up with, if it helps you, you could write set A again, since you're pairing the two up, but it's up to you. Then I'm going to start with 35 and pair it up with 30. Pair it up with itself. Oops. And then pair it up with 40. Last but not least, start with 40, pair it with 30, 40 with 35, and 40 with itself. So you're just making all possible ordered pairs. Like I said, you might come up with a different strategy you like better, or that clicks better for you. I start with each element in the first set, pair it up with everything in the second, and I just keep going through that first set that way. That's what I like. The last thing I want to talk to you about, you guys only have these three on yours. I don't know why I have more than that. When you have multiple operations going on, I just want to talk to you about the order of operations that you need to do. Okay? So for example, if we have, whoops, sorry guys. We have B prime intersects C prime. You have to find the complements first. You have to find the complements first, then their intersections. So you would start with B prime, or not B prime, excuse me, B complement. Remember, B complement, everything that's in the universal set that's not in B. So we would have left in there, we'd have 2, we would have 6, we wouldn't have 8, we would have 10, we wouldn't have 12, we would have 14, we wouldn't have 16, but we would have 18. Then we would have C complement. Then for C complement, we would have 2, 4, we wouldn't have 6, we would have 8 and 10, we wouldn't have 12, but we would have 14, we would have 16, You would have 20. Now for the intersection, what do they share? They share 2, they share 10, and they share 14. So when you start combining some set operations, that complement piece has to happen before an intersection or a union. You have to do the complement piece first. For the other two, we're running a little short on time, so for these other two, your first step would be the parentheses. Then your intersection. First step for this one, do your intersection, then the complement. So just kind of an order of operations for you. So if you have parentheses, do what's happening in there first. Do complements before intersections or unions. Complements are kind of that low man on the totem pole. We do them first.
Complements.
Okay.